we start mathematics, that we always first agree about what we are going to talk about. X is always the object what we are going to talk about, or any small letter, not capital letter. And then AX is always the statement about what we were going to talk about. And then always in our third level, we have connectors and stuff. We always want to ask ourselves how much of this statement about X is actually true. And there's two cases when it's actually really important. When it's true for all the X, and when it's true for only like one X. And that's why we have quantifiers, if we want to ask ourselves how much of it is actually true. When we write for all X, AX is true. That is when, for any X that you take, AX will be true. And when you write exists an X, AX, then there really does exist an X, that AX is true. So, first of all, we'll do an example now. So first of all, we will agree about what we are going to talk about. So when we agree we're going to talk about natural numbers, then we shall talk about natural numbers. So we can say X is an element of natural numbers. This is the symbol for natural numbers in mathematics. And this is what we are going to talk about. Okay, secondly, we make a statement with this X, and we say X plus Y is equal to 0. Okay, but then we should also say that Y and X is the element of natural numbers. We have to be precise in mathematics. We cannot have two variables and then exclude another one from what we are going to talk about. Okay, so this is our AX, this is our object, and this is our quantifiers. So when we were to say, for example, that for all X, there exists a Y such that X plus Y is equal to 0. That will always be true, because you say for any X, there exists a specific Y such that your X that you chose plus that Y which exists for that X is equal to 0. This is true. What I just said, do you think it was true or false? It was false, because I specified X and Y as elements of natural numbers. But what is natural numbers? There are 0, 1, 2, 3, 4. It should have been X and Y are elements of integers, such that Y or X can be negative numbers. Otherwise, how else are they going to cancel each other? And you have to notice what is the difference between saying there for all X, there exists a Y, and saying there exists a Y for all X. Because in this example, it is wrong to say that there exists a Y such that for all X, A plus Y is equal to 0. Because this is not true. Because for a specific Y, there isn't like all the X's in the natural number that will give X plus Y is equal to 0. Interesting example that I want to consider is when X is an element of the empty set. Okay, so I will compare it with something that is easier to understand at the same time comparing it with mathematics. When I say X is the element of human beings that can fly, and X is the element of the open empty set, not open. You have to be very precise, not open set, empty set. I always confuse it, but it's empty set. Okay. When I say for all X in the empty set, 1 plus 1 is equal to 3, this is true. Why? Because when I say for all X that you can find in the empty set, which you can because it's the empty set, 1 plus 1 is equal to 3, am I talking the truth? Am I lying? I'm talking the truth. Because here, when I say for all X, for all human beings that can fly, all human beings that can fly has leaves for hair. But that's saying if there is human beings that can fly, then that human being would have leaves for hair. But you cannot find human beings that can fly, so you are speaking the truth. But in the second part, when you say there exists an X, such as 1 plus 1 is equal to 2, you are speaking a false. You are speaking a lie because it's false. Because you're saying there exists such a thing, but there doesn't exist such a thing. For X is an element of human beings that can fly, it doesn't exist. So when you say it exists, this part, you're already lying. Quantifiers really makes you think, because at first you didn't really understand understand it. I didn't really understand it until I actually sat down and thought about it. What does this symbols actually really mean? Because the word if in mathematics is actually really important, and you have to remember that. Because when somebody says if, then you have to know if, not always if. And you have to remember that. That's one thing that I found confusing at the start of quantifiers. And also with the symbol implies, I also forgot the if, and that when I finally clicked about the if, then it all started to make sense. So keep that in mind when you do quantifiers, like if means if. To truly understand mathematics, you must really just sit down and think about what was told to you. You shouldn't just accept and never assume. Like, mathematics always connects to each other in one or another way. Like when you do functions and when you do trigonometry, for example, like they fit together in some kind of weird way. And when you actually find that connection, you can always like make an indication to yourself, like, oh, okay, that comes from that as well, and oh, this is why this was so. And you always have to try and keep an open mind and not plainly distinguish, okay, now I'm doing functions, now I'm doing this, now I'm doing this. Try and integrate it all together, because that's what it's all about. And that's what I try to do in mathematics. I sit and I study the textbook and I try and collage them everything into one so that I can understand it better, because mathematics isn't different, it's all one big thing that talks to each other.